When you get problems like these, you do want to set up a chart, just like we did when we were going through them. And so you do usually have two main things. In this case, he was there and back. So this is what type of problem? So this is a round trip problem, which means that we know that our two distances are going to equal the same thing. So we have our rate, our time, and that equals our distance when we multiply them. So for round trip, you're going to have there and back. Fill in what you know, solve for what you don't know. It's the whole point of all of these, right? We know his rates. On the way there, it was 40 miles an hour. On the way back, it was 60 miles an hour. His time, do we know how long it took him to get there? We do not, so we're just going to put a variable. Do we know how long it took him to get back? We don't. We know his total time was 6, though. So whatever his time was on the way there, if we subtract it from 6, what is left over will be his time on the way back. So this is just going to be that 6 minus his time on the way there. To find our third column, we always multiply across. So the first distance is going to be 40 times t. The second distance is going to be 60 times 6 minus t. And we said these two equal each other. So that's what we're going to set it up as. 40t equals 60 times 6 minus t. All right? And then we're just solving algebraically. Leave the 40t alone. Distribute that 60. 6 times 60 is 360. 60 times negative t is negative 60t. There should be a 0 there. We are going to add and divide, right? 144 miles, hopefully. All right. Notice that when you solve for t, you're not done. So if I kept going and added my 60 over, divided, I'm not done when I solve for t because the question was not time. What was the question? Question was distance, right? And so once you get t, you have to plug it back in, multiply it by 40, right? And figure out your distance. So always know what they're asking. Always know what they are asking when it comes to these questions, because if you answer it incorrectly, you're going to get it wrong. All right, so if you stopped at 3.6, which is what you would have gotten, 3.6 hours, something like that, you're not done yet. You have to plug it back in. Multiply that by 40, and you will get your 144. The freight train leaves Centralia for Chicago. At the same time, a passenger train leaves Chicago. The freight train travels at 45 miles an hour, the passenger at a speed of 64 miles an hour. If the two cities are 218 miles apart, how long will it take for them to meet? Once again, you are going to set up a chart. You are going to have two things. You have a passenger train and you have a freight train. And so you want to set those up with your rate, your time, and your distance. All right. And so I have freight train. That's my first guy here. Passenger train is my second one. The freight train is traveling at 45 miles an hour. The passenger train is traveling at 64 miles per hour. It says that the freight train at the same time as the passenger trains. They leave at the same time. This is kind of key here. That means we don't know the time, but we know that they left at the same time and they will meet at the same time, obviously, because it's their meeting. So if we don't know time, we do know it's going to be the same for both of them. Okay. Distance, always multiply 45 times that t, 64 times that t. Now for this one, these are the two that meet, which means distance 1 plus distance 2 equals the total distance apart. So we're not going to set these two equal to each other. We are going to add them. 45t plus 64t equals 218t. All right. Like terms. What do I do when I have like terms? What do I do with those?
You add
I add them. What is 45 and 64?
109.
109. There's not a T there. 218. Divide. They were very kind, weren't they? T equals what? 2. Should be 2, right?
Yeah.
Right. So how long will it take? We're done. How long will it take is time. That's actually what our variable was. You don't have to plug it back in. We have answered the question. It was 2 hours. Mixture problems involve combining different substances to solve a problem. Make a table similar to the ones that you've done for coins, interest, and motion problems. Read the examples and collect the necessary facts. So when you think of mixtures, this can be chemistry mixtures. This can be like the examples that they're about to do, like feed for animals. You can take 2 different substances and they can have part of the same type of substance in it. So like with chemical, you'll say this is 20% alcohol, meaning 20% is like alcohol and 80% is water or whatever. And then the other one's 35%. And what happens when you mix those 2 together? What does your final thing look like? It's going to be used in chemistry all the time because it's really important that if you're mixing this substance with this substance, you know how much it is because some of them react, right? And so this is used in a lot of chemistry problems. The example that we're about to do is feed. So when they're doing animal feed, they will make sure that certain nutrients are mixed appropriately depending on what they want to do with the animals. And so you'll see these types of problems in lots of different fields. So let's look at this first example. We are going to set up tables for all of these. A feed store owner wants to mix corn and barley to make 150 BUs. That is a measurement for this of silage additive for cattle feed. Okay. If the corn costs $3.80 and barley costs $2.60, how many bushels of each grain would he mix to yield an additive worth $3? Okay. So we have bushels of corn and bushels of barley. All right. And so when we're looking at this, anytime you see this little slash per bushel, this is going to be telling you you're going to do some type of multiplication here. All right. Because we have $3.80 per bushel, $2.60 per bushel there. All right. And we want to know how much he needs to mix because he wants a specific cost when he gets these. So we are going to set up a chart much like we've done in the past. But this time we're going to look at 3 things instead of 2. And so when you do these charts, you want to consider the fact that you have 2 things that you are mixing, and then you also have a final mixture. All right. And so I am going to set up a row for the corn. I am going to set up a row for the barley, and I am going to set up a row for my final mixture. All right. And then I have to consider what I'm talking about. In this case, I'm talking about bushels. That's what our little BU measurement is. I'm also talking about a price. And then I'm talking about a total cost. So I am going to set up the 2 items that it has referred to. In this case, these are the 2. Sometimes it will be chemicals. We will do some of those. And then your last one is always going to be that final mixture, whatever it is. All right? So this is pretty straightforward for all of them. As you read these, you're going to say, what units am I talking about? What are my units here? Well, my units here are bushels. So in this case, I'm talking specifically about a number of bushels here. My number of BU, my number of bushels, okay? The next column is going to be whatever thing you're going to multiply by. If it is a chemical mixture, very often this will be a percentage. In this case, it's a dollar amount. So this is a price per bushel. And then what is he concerned about? Well, he's concerned about an overall cost. So this is going to be my total cost. Now, these columns will also multiply across, okay? So when I start filling this in, I am going to multiply across as I get there. Here's the thing. We have to figure out what we don't know. What are they asking? Well, they're asking how many bushels of each grain, all right? So do I know how many bushels of corn? Well, I do not. So for these, you can either use the variables that match. So let's say I wanted to say, well, C stands for corn. All right. If that's the case, I need to make some sort of note. That's what I'm finding when I find C. Because we actually have two things we don't know here. We don't know corn and we don't know barley. So we have to write one in terms of the other, or we're going to end up having two variables, which we haven't gotten to yet in our math world, okay? And so if I say, well, corn, we're just going to say that that is C. We don't know how much it is. What they did tell us is how much total. So how many bushels does he want total? Well, he wants 150, all right? And so I also know the number of bushels I'm going to have finally, all right? Well, how do I get to those? Well, I would have to add the corn and the barley, right? Does that make sense? So if I had, let's say, 50 bushels of corn, how much barley would I have? 100. What did you do? You added the 2, which means you technically took 150 and did what with the corn? You subtracted. And so my barley is going to be this 150 minus however much corn I have. Does that make sense? So when they give you a total, you're likely going to subtract back into one of them. Okay? Questions? How much does the corn cost? Did they tell us? Okay. How much does the corn cost? $3.80, right? So I'm going to put that in my price per bushel for my corn. Did they tell me how much my barley cost? $2.60, right? Did they tell me how much my mixture is going to cost? This column you do not add down, okay? You don't add down here. They told you how much he wants it to cost. How much does he want this to cost? $3. All right? So you add down for this column. You multiply across, but you do not add down for that center column, all right? That includes your percentages. You're not going to add down for your percentages either, okay? Total cost, we multiply across, all right? So my corn is going to cost $3.80 times however many bushels I have. My barley is going to cost $2.60 times however much barley I have. And my total is going to cost $3 times my total bushels that I have altogether. This last column you will add down because the cost of the corn plus the cost of the barley should equal the cost overall, right? And that is my equation. This last column will create my equation. My equation will look like this. 3.8 times C plus 2.6 times 150 minus C equals 3 times 150. What is 3 times 150, by the way? 450. There we go, 450. All right. Now, I will say in the book, they use the trick to get rid of your decimals. Each of these has one decimal, right? Well, at most one decimal, right? So you can use your trick to get rid of your decimal. Move everything over one decimal, right? And you have 38C plus 26 times 150 minus C equals 4,500. So if you're following along in your book, they got rid of their decimals. Okay? How do I solve this? Well, I have a basic equation here. Distribute, combine like terms, numbers to one side, variables to the other, and divide, right? And thankfully you have a calculator, so you don't have to do all this good stuff in your head. So we have 38C, 26 times 150, 39, right? 300 times 13, I think. Minus 26 times C. All right. What do I do now? I have like terms. What are my like terms? C's. Yeah, my C's are like terms. 38 and negative 26 give me 12. And I can move this 3,900 over, right? That's perfectly divisible. 600 divided by 12 is 50, right? Should be 50, right? 60 divided by 12. All right, what did I solve for? What did I solve for? What does that C represent? Go back to your chart and tell me what the C represented.
Number of bushels.
Number of bushels specifically of corn. All right. What did the question ask? How many bushels of each, right? Of each. So for corn, I have 50 bushels. They have to add up to 150. So to find this guy, 150 minus 50, how many bushels of barley? I have answered my question. This is the other type of problem that you are going to see. You are going to see percentages, all right? So, you are still going to have three things, and you are still going to have a final mixture, okay? The difference is that instead of like pounds and dollars per pound or something like that, you're going to have a unit and then a percentage of it, okay? And so let's read this. Nickel, silver, often used for coating tableware, is an alloy. What is an alloy? A mixture of two metals, right? It contains 15% nickel along with copper and zinc. How much pure nickel must be melted with 70 pounds of nickel silver to make an alloy that is 20% nickel? Lots of stuff going on here. All right? So, we have nickel silver and pure nickel. Let's see what we have here. How much pure nickel must be melted with nickel silver? That's like my hamburger and sausage, okay? Does everybody see? Those are my two things that I'm mixing. So my two sections here are going to be pure nickel and the nickel silver. All right? The bottom is going to be my mixture to make the alloy, which is just a mixture, okay? So, my units. What are my units? Pounds, right? We mixed pounds of hamburger, right? Or bushels of corn. My units here are pounds. So this is going to be the pounds of metal that I have. The next column is the percent of nickel, right? So it is 15% nickel. So this guy is going to be percent nickel. And this is going to be the pounds of nickel that I have. All right? So let's talk about nickel. How much pure nickel? How much? Do I know how much nickel? I don't, do I? So I'm going to say, well, X is going to equal my pounds here of nickel. So I'm going to say X, I don't know. Must be melted with 70 pounds of nickel silver. How much nickel silver do I have? 70. If I add how much nickel and how much nickel silver, I will get my alloy. So I just add down. This is going to be X plus 70. That column adds down, okay? Let's look at the percentage. My nickel silver. So nickel silver contains how much silver? 15%. So nickel silver is 15% nickel. What percent of nickel is nickel? It is. Nickel silver contains 15% nickel, okay? Nickel contains 100% nickel, all right? 100% nickel. Our alloy wants to be how much nickel? 20%. Does everybody see that? Everyone has its own percentage. All right, multiply across. That's how you do it. So change it to decimal. 100% is 1. 1 times X. 15% is what? In decimals. 0.15 times 70. 20% is what?
0.20 times.
There we go. This column adds down. Wait, let's finish it. X plus 0.15 times 70 equals this guy, 0.20 X plus 70. It works the same as your other mixture. You just have percentages instead of dollars.